So in this one, yeah, it's comparing more than two groups for a one-way repeated ANOVA. Or more than 2 time points with the same group measured over time. If you're just comparing between different groups where it's a similar time point, then you can use the alternative, which would be between factor, which I've done on a different video. So this one's when you're measuring over time, so the same group over time, where you have more than 2 comparisons. But it still has the same assumption of normality that the between ANOVA has. So we can check that first by going to Analyze, Descriptive, and then Explore. And then I'll reset this because I've already done it, but we just copy and paste them through. And then we can go to plots, and then typically I just turn these off and then put normality plots with tests. So we're going to get 3 p-values here, and we want them all to be higher than 5% or 0.05, which they are. So here for day 1, day 2, day 3, they're all above that cutoff. So we have normally distributed or parametric data. So now we can run the ANOVA without having to log transform or anything like that. So for this, we can get Analyze, General linear model repeated because we have a repeated factor. And then I'll just reset this, but basically you just go time 3 levels because we have 3 time points. You change that depending on how many time points you have. And then we basically just want to copy and paste these 3 days into the 3 spaces that we've now made available. And now we can go to estimated marginal mean. So we're going to run the ANOVA, but then if there's a difference, we need to know where that is. And here I'm just selecting Bonferroni rather than SIDAC. And then for options, we don't need Levene's test for this type of ANOVA. Mean and standard deviation, but you can choose what you want. So now it's done the repeated ANOVA, we need to look for this first, which is basically the repeated ANOVA equivalent of Levene's test. So if this is higher than 0.05 Mauchly's test, then it means the assumption has been met, similar to the parametric test with Shapiro-Wilk, and it is just, so that's fine. But if it hadn't been met, we can use these corrections, the Greenhouse-Gessier correction. But when we go to our main output box, which is this, the within subject effects, we go to time, which is what we call our factor. We have that assumption met, so we can take this top row, and it's telling us that there is a significant effect across our ANOVA, but we just don't know where that is. If Mauchly's test hadn't been met, we could use this Gessier correction and we just use the row below, but it doesn't matter because they're both significant. And now we need to find out, okay, where are these differences? This is what this Bonferroni adjusted post-hoc comparisons box tells us. So we have these numbers 1, 2, 3, they correspond to the days. So if we go here, 1 is day 1, 2 is day 2, 3 is day 3. Okay. And it's basically telling us when you compare all of them against each other, they're all different. So every group is different from each other, or every time point is different from each other. So the ANOVA has a significant effect. And then each of the 3 days are all different from each other as well. And that's how you run it. Okay.